Hello and welcome to Func Prog Sweden. We are back. First up, I would like to welcome all our recurring viewers. Thank you for supporting and coming back and joining us live at Func Prog Sweden. Thank you very much. And then to all new viewers, welcome to Func Prog Sweden. This is the meetup and channel where we explore functional programming, such as Erlang, Haskell, Clojure, Scala. We also explore functional programming concepts. We have also explored functional programming in C++, Java, and more. Yeah, so if you're into and want to learn new things and want to explore what's the next paradigm, stay tuned. First, agenda. Me, Magnus, I will do short intro, and then we'll head over to the first presentation in today's meetup, F# Down Under by Sashan. And then we'll head over to our second presentation, Can Functional Programming Be Engineering by Alexander. And then as always, for those who would like to ask more questions, elaborate questions, thoughts, speak to other people doing functional programming, join the post-show chat on the Discord server. You'll find the invite either in the meetup page or here in the YouTube page. But first, let me thank Beat for sponsoring the Func Prog Sweden meetup. Beat is an IT consultancy company with offices in Stockholm and in Ho Chi Minh City. They are experts in functional programming. If you want to know more about them, check them out on their webpage, adabeat.com, or in social media. Then the schedule for the coming period. 8th of October, we're back at Kivra. So if you're in Stockholm and want to meet other people live and talk to people, have some good snacks, make sure to sign up and come to Kivra. Then we're back 5th of November online, and then 3rd of December again. Then, of course, we're going to continue to plan the coming meetups for the coming year. Then, if you want to support Func Prog Sweden, and of course you want to head over to Meetup and join the Meetup community, and make sure to subscribe on the YouTube channel. Finally, last but not least, join our Discord server to make sure to chat to people and make sure to be able to ask more elaborate questions, which we head over to now. Questions. If you have questions during the live stream, either shoot them in the chat in YouTube or on the Discord server to ask them. And I'll make sure to convey the questions to the presenters. With that, let's start, and welcome to our first presenter, Sashan. Hello, Sashan, and welcome all the way from Australia, Melbourne.
Hello, Magnus.
Hello.
Thank you for having me on the show.
Yeah, you're welcome.
Yes. Yeah.
Hit it away.
Right. Hello, everyone. I'm pretty happy to be here on Func Prog Sweden. I'm going to talk to you about F# Down Under and how we use F# in Australia. I was going to call this talk something more practical, like F# pragmatic use cases or F# real world use cases, but I opted for a little slightly different title to make it more exciting. And I put a little picture of an AI generated kangaroo down there, just to, uh, and the kangaroo is actually meant to be holding a pouch with the F# logo, but the AI didn't quite generate the logo correctly, as you can see with this these Gen AI things. They're a bit they're a bit weird sometimes. But anyway, I should introduce myself. My name's Sashan. I have been in the industry for well, quite a while now, about almost 2 decades or so. Most of the my work's been with C and C++. And more recently in my career, I've started using F sharp. And I use it in a group, in a team at the company I work for in Australia. And I've just found that I've actually enjoyed the work quite a lot, and I've enjoyed using the language. Um, I did work for the same company Magnus did several years ago, except I was in the Australian office and he was in the Swedish office. And I have some interesting posts on Stack Overflow. If you've ever wanted to know how to open a file in Vim and you've seen this answer, that was me. At one point in my life, I used to hang around there. Um, but so I'll just get on to the real subject of my talk, which is what is F hashtag? So I'll tell you an interesting story. I was describing that I was going to be doing this talk about um, this programming language, and a family member said to me, "So you're talking about F hashtag?" And I kind of laughed a bit, and I was like, "Oh." It kind of crossed my mind that there's this, generational gap between what people see now as a hashtag and what we saw in around about the early 2000s when C sharp and F sharp came out as a sharp symbol more. But anyway, just to clarify, I'm going to talk about a language called F sharp. It's not called F hashtag, in case anyone has any confusion about that. It is a Microsoft-based language, and it's kind of like a sibling language to C sharp, except the functional equivalent of it. It was created by an Australian, Don Syme, ironically. Although I find that a lot of people in Australia don't even know this, and the industry here is we actually don't use it quite, we don't use it a lot in Australia. I think Europe probably has more use cases of F sharp than we do over here. Um, and why am I doing this talk? Well, I feel that I'm generally happier using F sharp in my work life. I've used C++ and C mainly before in the past, and Python and yeah, and Bash and a few other languages along the way. But F sharp has probably given me the most fulfillment than any of the other languages that I've used. And it's kind of able to blend a pragmatic approach. It's also expressive enough to satisfy your needs for defining um, types, and it gives you enough integration because you can. It gives you enough parts to integrate with .NET. So .NET obviously has a huge ecosystem, so you've got that whole ecosystem under you that you can leverage. And I think I remember when I was at university doing Haskell. I think one of the remarkable things I found when I'd written a program in Haskell and it compiled, I found that the program just worked. Like it was the compiler verified that the program was logically correct. And I have a fairly similar experience when I write code in F sharp. I find that once it's past the compiler, it tends to work correctly at runtime. Um, so what this talk is going to be about is I'm just going to show you different slices of F sharp and how I've used it in my work life. And it's not a tutorial about F sharp. I'm not going to show you how to write a for loop or if then statements or how to do match clauses. It's basically it's just a section or slices of different topics um, uh, that I've encountered while using F sharp as a software engineer. So, so Let's start with, I think one of the things that made F sharp stand out from a lot of the other languages. Um, so around about 2010, I noticed F sharp. It was a Microsoft only language then because if you wanted to use it, you pretty much had to use Windows to use it. I was at that time a C++ developer working on QNX, which was a real-time operating system. I was using, I think it was the Whatcom C++ compiler, which was from like 1987. It was a very old compiler. But I did bump into this F sharp language, and because I had a sort of passing interest in functional programming languages, I was like, oh, let me have a look at this. Let me see how it works. I see they have this model for dealing with concurrent programming situations. And other languages at the time, like the popular ones, C Sharp and Java, they didn't have a model for handling asynchronous workflows or concurrent programming. Um, so typically the problem that people face in these languages is what you want to do is you want to be able to um that's a shame my slides don't go all the way down. Oops, got to work on that. But basically your main flow of the program will run a will want to say you want to download something, then you pass the a callback function to the function that performs the download. And once it's got the results, the callback function will handle the results of that download. So you can see it, and this is a C code, so you can see it happening here. I download something given a list of URLs or an array of URLs. I get the results and I call the callback function to operate on those results. And the callback is this here. So what the problem here is that your flow of control tends to be inverted. There's an inversion of control that goes on. And you also have to maintain the state of variables between the main thread of execution and the main thread of execution and your callback function. So that means you have to manage the lifetime of that variable if you want to pass information between the main thread and the callback. Um, the other thing that happens is you'll have to worry about threads. If you don't want your main thread to be blocked, you have to put this into a thread pool and manage that yourself. And especially in C land, you'd have to do something like that. Um, so essentially what we want to fix is we want the benefits of synchronization without the drawbacks. We don't want to have to follow the flow of control in two places. We want to have the result returned where we asked for it. And we don't want to lock the threads. We don't want threads to be blocked. We want that thread resource to be free and released to the operating system so that it can use it and do whatever it wants. And F Sharp provides a model for this. It provided a way to do this. The other thing was the state variables. We want variables that existed in our main flow of control to also exist at the callback site. Um, so F Sharp provides a method to do this using what's called async. So async, as you can see here, is, well, it's basically looks pretty similar. Simple. It's just a block with an async keyword and in the squiggly braces. The only funny thing are these let's bang symbols. And that's basically, if you're familiar with like C sharp, that's basically saying await the response. So that's the point where the synchronization happens, um, and the result is returned, and then the flow of control continues. But this looks all very similar. Like it looks very simple, and there's a lot going on under the hood. Uh, and all of that complexity is just very elegantly hidden from you. So, I mean, I know you're not meant to say it in functional programming languages, but this async computation expression is essentially a monad, and it's under the hood. There's a series of bind calls that are chaining each await over here to the next await. There's also the use of closures and happening in the background that ensures that the response here is available at the response here is available to be used over here in this line here. Um, so it just gave you or gave the programmer a very elegant way of dealing with the problem of concurrent programming. Um, the other thing I should mention is that the use of threads in .NET, threads are managed by the .NET runtime. So at this stage of execution, while it's awaiting, the thread is released back to the runtime. So that thread is available for use by anything else in the system. It doesn't the async runtime doesn't hold up the CPU. It doesn't hold up resources on the host machine. And then when it returns here, the th it might this flow of this part of this code here may continue in the same thread or in another thread. So what's the catch? I mean, is there anything like weird that might happen? Sure. If you're tempted to go off and try using async and trying some F sharp, I thought I'd just throw in this here as sort of just a way to help you. Um, just something to watch out for is if you try and use if you try and use a sequence expression, so here I'm building up a result uh, in a loop, and this is yielded into the list. So two square, whoops, wrong thing. So two square brackets are an array, are a list, I should say. Um, so you'll get this compiler error. So what's going on here? It's just a case of the thing is a sequence expression. What we see here in this loop, in the for loop, is also a computation expression. So it's shadowing or overriding the definitions that the async computation expression defines, and the bind underneath the hood, a let bang is translated into a bind. It has a different bind than the one in the for loop, which doesn't exist. So yes, there's a way around this. You can do things like what I'll show you in the next slide is just don't await it. If you look on line 5, I've taken away the bang, which means I just get the async object returned. And then at the end, when the loop has built up the list, I just pass it into something like async parallel and use it like that. And then that means that the whole thing's executed in parallel, asynchronously in parallel. That's one way to get around it. And the other way is to use async sequence, which is it's not built into F sharp, but you can download it from NuGet. And that's an example code here. So in with async sequence, you just replace your async computation expressions with an async sequence computation expression instead. And you can use your for loops more or less the same as you did previously. So, I should also mention, just for completeness, that there are also task expressions. So, Microsoft added task expressions just to have so that they're more compatible with C sharp. C sharp natively uses tasks, or I should say .NET generally natively. Tasks are the predominant thing in the .NET layer. So whenever you're talking to a .NET library, you'll often find that if it's doing anything asynchronously, it's doing it using a task and not in async. And the F sharp maintainers added this just so that it makes compatibility with that layer easier. The few things you might have to watch out for here are they don't support tail recursion. So basically don't use recursion in tasks if you want to use them. And they start immediately. So as soon as you call the task, it'll start. Whereas async, you have to um, pass it through async run synchronously to have it all unwrapped and all executed. Um, so to wrap up, why so why was async important? Um, it came out like if think about it, F sharp had async in 2007, whereas had a model for concurrent programming, which is great. Like it's amazing. It really was a thing people struggled to do like easily in other languages. And I think these days we're in 2024, if you were to think about starting a project and um we're looking around at different languages, you'd be hard pressed to pick a language that did not have support for async. Like you really would want a language that has support. When I say async, I mean support for concurrent programming. You don't want to be working with languages that don't have that support, especially if you're doing stuff with the web or you're doing a lot of, request response type of work. Um, yeah. And so it's quite interesting just to see how pre-science, I should say, or how like future-proof F sharp was with the fact that it had this ability back all the way back in 2007 when most mainstream languages weren't really concerned about this. Um, yeah, and I just like to leave you with a thought about it. How I assume a lot of you have your own favorite languages. It would be good to have comparisons between how F sharp does it, or I would like to learn as well about how other languages handle this problem of concurrent programming in how other languages handle that problem. Um, On to the next section, uh, type providers. So why am I talking about type providers and what are type providers? Well, why am I talking about it is because it was actually one of the things that saved us a lot of work. Like, I think it easily saved us weeks, probably a few weeks of work and back and forth, and in one of the projects that I've been working on. So I think it's worth talking about because anything that saves you work is probably an efficiency enhancer and is good for business. So uh generally I guess like a type provider is what it says there. It infers a schema and generates types. And that sounds kind of very abstract. But it's really useful for, working with unstructured data, XML or JSON. And in our use case, we had a lot of unstructured XML to essentially deal with. And what we did was we put it into the type provider, and then, voila, out came a set of structured types for us to use that we could write XML documents with and pass those XMLs as requests to the third-party APIs. Um, so here I just have an example XML file. You can see it's basically a list of books, and each element inside the list are two books. And the type provider code itself it's really very simple. Simple. If you want to create types from this document, this example document, basically all that's required is something that looks like this. As you can see, that's very easy, and all I've done is I've provided a path to the file itself, and then loaded the data, and then told the just ran a loop and to print out the book title, just as an example. Um, so I could do something more exciting. I have the example here, so I'm gonna just switch over to some code, just so and run it. So we should be able to see. So just give me a moment. Is there? I don't know what this is. Um, I'm being very brave here, going off into code land. Um, task versus async. XML type providers. Let me share the screen. Uh, this is the one. Sharing a different screen, so hopefully you can see. Here we go. So I would think one thing I want to also show you with F sharp is um, the fact that it's scriptable. So I can write this here, and then I can hit, like, I'm using VS Code, and so there's some key bindings here. But if I just select it and hit Alt Enter, it puts it into the interpreter below, the FSI, and it runs it. As you can see in this, let me make the screen a bit bigger. And then I can extend this loop, and I can say, oh, maybe I want to print the book dot the year as well. And I want %d, that'll work. And then I run the loop again, and we should see it come out here as, yeah, Chris Smith, programming F sharp 2010, and then Don Symes' book below. So that's um, that's an example of an F# script. This is the type provider loaded out of the books.xml file. And yeah, this is basically just the loop that loops through the data, which you can see is, it's this here that the type provider's generated for us, which is really, really handy. And if I look at book, I can see all the other elements of that XML document that I can reference here for each book. So that's one of the nice things about F# is that it's scriptable and just makes the iteration process a lot easier. And I'm just going to keep talking a bit about the IDE because I think it's important because F#'s a type inference language. So you don't necessarily have to type annotate things. It works out the type based on type inference. But as a human, it's really handy just to be able to hover over the value and read what the type of the thing is. Um, I think it's really difficult to do programming in F# without that facility there. And the other nice thing about the scripting language is that I can essentially give this file to anyone, and as long as they have the .NET runtime installed, sorry, the SDK installed with F#, they can actually just run this and it'll work. There's no dependencies that they have to pull down because all the dependencies are you can actually just specify as #r references in the file. So if I wanted and pull them down from NuGet, or you can #r reference, or you can load another file from this file, essentially. So as long as the files you're packaging, sending to someone or contain whatever you need, then it's fairly self-contained compared with other scripting languages. Um, so I will go back to my main presentation now. Um, Let me find it. There we go. Yes. Um, so to wrap up type providers, they're they let you efficiently work with unstructured data. They're a great time saver. They were a great time saver for me. And as a question for you, how have you worked with unstructured data in your projects? What have you done to like sanitize it or make it something that you can live with daily? Um, yeah. I I'm thinking that I've been talking for about half an hour now, so I'm probably gonna skip a bit quickly over the next following slides. I think I'll just talk a little bit briefly about domain-driven design. I think that's actually one of F#'s really strong points, and I think it's really useful. Um, F# has discriminated unions and records. It's one of the few languages to have discriminated unions. And discriminated unions allow you to describe, they basically describe, you can say, I want this, or this, but none of, like it has to be one of them, but not any of the others. It gives you that choice. Um, Whereas other mainstream languages just don't have that type. And when it comes to describing a domain, the F sharp code that you write, excuse me, tends to be rather it tends to reflect the domain very clearly. There's not a lot of syntax in there that just detracts someone from uh, what the domain is trying to convey or what the type system is trying to represent in the domain, which means that you can actually take F sharp code and you can show it to business stakeholders and you can say to them, look, this is what the model looks like. This is how, for example, this is how I'm modeling your ordering system for coffees. Um, we have a record here that describes a coffee, which is how strong you want it, um, how large you want it, um, and you show that to them, and they understand it because it's not cluttered with a whole lot of weird syntax. Um, and I think that's actually one of F Sharp's strong points. It's one of the things that's really, really good at is being able to like if you like building things using domain-driven design, then F Sharp is incredibly useful like that. Um, I think yeah, like I said, I'm just gonna skip over a few of these slides just because of the time. I'm gonna stop here and talk a little bit about REST. Uh, just because it's important to realize that with REST interfaces, typically you're talking your REST interface wants to serialize to JSON, but JSON doesn't support discriminated unions. So what you want to do is you want to remove your discriminated unions from your types, from your contracts, and flatten them to something like this instead. Um, that's typically what you want to try and do. Uh, Otherwise, when you serialize that discriminated union into JSON, sure, the serializers just generally can't handle it, but your consumers, the other people on the other end, they typically won't have a language that deals with options or discriminated union types very well. So when they see that JSON object coming through, it looks really strange to them. It might have like this weird value field, and underneath that value field, there is the actual pipe that you want. And it doesn't, yeah, they tend to fuss and complain about that. So it's probably best to flatten them into something like you see over here. Um, Let me just keep going. gRPC, yeah, gRPC is a lot more friendlier with F sharp, essentially because protobuf, gRPC uses protobuf underneath, and protobuf supports optional. It supports optional as well as they call it one-off, but one-off's also the same as discriminated unions. So your F sharp domain types just map over pretty seamlessly into protobuf. So that flattened example that I had in the last slide ends up just looking like this with the one-off protobuf type. Um, yeah, it's perfect. Let's skip this. I'd like to talk a bit about what people find difficult about F sharp or about functional programming in general. So I think when I was learning, I had to unlearn a lot. I had to unlearn like certain things that I'd picked up from object-oriented programming. I had to learn how to write programs using immutability instead of mutability. I had to learn recursion. I had to learn tail recursion. Um, yeah, so there I had to learn how to use higher order functions instead of writing a loop to do something, how to use a higher order function to do it, and how to use how to there were common patterns that I built up when looping over data that I just knew how to do by iterating in a loop. And those, I didn't know the mapping between uh, those loop situations and what I needed to use in higher order functions. For example, I didn't know like zip, for example. I didn't know about zip and I didn't really understand how to use it properly. So I think those hurdles probably keep people away from functional programming languages. Uh, I always find it very. I just find it very. I just haven't. I guess very interesting. It's probably not the right word, but very just hard to square the circle. Like, for example, you could say to someone, "Oh, like F sharp has this model for async programming." And it solves this problem. Like it really is a problem, and you want to be able to asynchronously send requests over a network to some server and get a response back, and it does it better than it does like Java. It does it better than C++. It does it better than C sharp. Um, let's say you're talking to back in 2007 or 2010, you were talking to someone about async. And they would look at you and they would like kind of like, you know, for all the talk about choosing languages based on pragmatic considerations, very few people actually do. And a lot of them, for them, I think what's going on is that the pain of learning a new way of programming is the pain of learning a new method of programming and is greater than is greater than the benefits that they'd get from having async, for example, in the language, or that shiny new feature that makes a certain task a little easier. So people just tend to want to avoid pain. And I think, just even learning how to program with immutability, it is painful at the start. Um, and I generally think, yeah, that the pain of learning a new language is for a lot of people is greater than the perceived benefits that that language can bring. Um, yeah. Um, I think I'll end here. And if you have any thoughts or questions, please feel free to post them in the chat. Um, and if you have, especially if you have any more questions or any more details, because I know I've gone through things really, I think, very quickly. So if you want more information about more detailed information, yeah, feel free to ask in the chat in the Discord server, I think. Uh, so Magnus, I think back to you guys.
Thank you very much,
Thank
Sashan. Thank you very much. Great presentation. Thank you. It's a good selling for F sharp and functional programming. It's a good selling point. Like the enjoy, what would you call it? The joy of programming is back from the pain of development.
Yes,
Yeah,
yes, exactly.
yeah. Especially if you do it eight plus hours per day.
Yes,
Yeah.
exactly. You want your programming languages to like, I feel like, hey, I'm spending 8 hours a day doing this. I want to work with something I like working with, you
Yes.
know. I think developers should like fight for that. Like they should, fight for the languages they want to work with and not have to, yeah, not have to just live with the status quo that some manager tells them to use. Oh, you got to use Java. Like, I'm like, yeah, go to hell, mate. I'm not doing that.
Okay.
Yeah.
Yeah. How long time did it? Maybe you said it, or maybe I missed it. How long time did it take for you to go be productive in F sharp? Like you started learning, and then was it like days,
Uh,
weeks?
it was, let's see. So it's a bit funny with me because like I sort of looked at it in 2010. and it was on Windows at the time, but I wasn't really going to make a switch over to Windows programming. But I learned OCaml. Actually learned OCaml, and if you know, F sharp's derived from that family of languages from ML. So I'd had a bit of a go with OCaml, and I knew how to do the basics there. And so when it came to picking up F sharp again about five years ago, I picked it up again when .NET Core came around. So .NET Core is Microsoft's implementation that's platform independent. Um, I picked it up then, and I was productive. I was productive fairly quickly. I mean, like, I'd like to think I used it relatively functionally, like without mutation for most of my use cases. Although, I mean, you can't avoid mutation in some cases, but um, I think it's like for me, it wasn't too hard to pick up a new language, but I've been doing this for a long time, so. I think the hardest thing for me was unlearning old ways. That's
Mm.
probably the hardest bit.
Yep.
You do have to shift some of your thinking. Yeah.
Again,
But
thank you very much,
yeah.
Sashan. If you have more
Thank you.
questions for Sashan, please join the Discord server afterwards and ask more questions or thoughts or input towards Sashan. Yeah, thank you.